Hello and welcome to our discussion today. In the first section of chapter 3, we're going to continue to talk about quadratics. Today we're going to talk about solving quadratic functions. Right, so we want to solve quadratic equations or functions by factoring, and then solve quadratic equations graphically, solve equations algebraically, or say by algebra. And then we want to use quadratic modeling to solve real-life problems. All right, so let's start with the first part, solving quadratic equations by factoring. Just to let you know, there's a lot of content. I have to review some material for you. So there's going to be a lot of review and some new information. All right, so let's talk about quadratic vocabulary before we get started. And then we want to talk about solving quadratic equations by factoring. So talking about quadratic vocabulary factoring, you need to know the difference between factoring, solving, and finding the x-intercepts. So on a test, I'm going to ask you to do one of these three. And if you give me the answer for one of the other two, then it's going to be incorrect. Quadratic vocabulary you need to know. So lots of terms in discussing quadratics, which we've already started. Then we're going to talk about quadratic equations by factoring, solving. And so you need to know special product patterns. You need to be able to find common monomials or distribute out common factors. I'm going to teach you the diamond and box method, and then we're going to use the diamond and box method with coefficients that are greater than 1. All right, so first off, we need to talk about the difference between factoring, solving, and finding the x-intercepts. So I have an equation, a quadratic equation here, and the, let's say, commands or the instructions to factor, solve, or find the x-intercepts are all related, but they're not exactly the same. So they're siblings, but they're not identical to each other. So if I ask you to factor, then you're going to find the monomial or binomial that when multiplied by the other monomial or binomial, so this binomial is two terms, produces your quadratic function. If I ask you to provide the roots, zeros, or solutions, you're providing the values of x that make the quadratic equal to 0. So what we're looking for are the values of x on the x-axis where the graph crosses the x-axis. And then finally finding the x-intercepts or the coordinates where the graph crosses the x-axis. And we can use either the process of finding the roots, zeros, or solutions, or factoring then to find the x-intercepts. Okay, so very important to understand these distinctions between factoring, solving, or providing the roots and zeros, and finding the x-intercepts. So know the difference between these three. All right, so zero product property, this is something you learned in algebra, and it says if a times b is equal to 0, then either a must be 0 or b must be 0. All right, so in the process of factoring, we had this quadratic y is equal to x squared plus x minus 6. We said we're going to factor it, and then to solve, we're going to set the factored quadratic equal to 0. And this means, if this is the case, that either a is 0, as this factor x plus 3 is 0, or x minus 2 is equal to 0. So that means either x plus 3 is equal to 0, or x is equal to negative 3, or x is equal to 2. All right, so the zero product property says if a times b is equal to 0, then a must be 0, or b must be 0, or they're both 0. And we're going to use this information in order to solve a quadratic by setting y equal to 0 and then finding the values of x that make the statement true. And that happens when a is 0 or b is 0. All right, so that's the zero product property. All right, so the question here is find the x-intercepts. So y is equal to x squared plus x minus 6. So I'm going to factor first. I'm going to find the values of x that make this statement true, setting y equal to 0, because y is 0 at the x-axis. So y is more than 0 here and less than 0 here. Y is 0 here, so we want to find out where y is 0. That's where the graph crosses the x-axis. So we're going to solve for y is equal to 0. Find out that x is equal to negative 3 and 2, and then we're going to use that information to construct our x-intercepts as a coordinate pair. So I need an x value and a y value in those parentheses. All right, so quadratic vocabulary, basic definition or form of a quadratic equation. We talked about standard form as a form y is equal to ax squared plus bx plus c, where a cannot be equal to 0, and it has the shape of a parabola. So if we take a look at these two first equations, they both meet the criteria. Even though I don't have a bx or a c for the second quadratic, it still meets the criteria, because the only criteria in this function is that a cannot be equal to 0. If a is equal to 0, then I end up with bx plus c, which is a line and not a parabola or a quadratic equation. All right, so y is equal to ax squared plus bx plus c. A cannot be 0, otherwise we don't have a quadratic. All right, so let's talk about, I talked about monomials, binomials, and then we're going to talk about trinomials. So mono means one. I have one term. So x squared is one term. Two terms would be x squared minus 4, or x squared plus 4x. And then three terms, x squared plus 4x minus 4. So a quadratic can be a monomial, a binomial, or a trinomial, so long as it meets the criteria for quadratics in the previous slide, where a cannot be 0. So these are the terms to remember. Monomial means one term, bi, like as in bicycle. Two terms, tri, as in tricycle. 3 wheels, 3 terms. Okay, so let's talk about factor. A factor is an integer divisor which produces no remainder. So 7 is a factor of 35, because when I divide 35 by 7, I end up with 5 with no remainder. Quadratic factors are a monomial or binomial, which when divided into the quadratic results in a monomial or binomial with no remainder. So x minus 2 is a factor of x squared minus 5x plus 6. If I divide x minus 2 into x squared minus 5x plus 6, I end up with x minus 3. Or I can see x minus 2 times x minus 3 is x squared minus 5x plus 6. So x minus 2 is a factor, and x minus 3 is a factor of x squared minus 5x plus 6. Because if I divide either one of those into x squared minus 5x plus 6, I end up with a monomial or binomial that has no remainder. All right. All right, so let's talk about perfect squares. Perfect square is a product whose factors are the same integer. So 25 is a perfect square, 49 is a perfect square, and you can think about some other perfect squares. 4 is a perfect square, 9 is a perfect square, 16 is a perfect square, 64 is a perfect square, 81 is a perfect square, 9 times 9. So a perfect square is a product, 25 or 49, whose factors, 5 times 5 or 7 times 7, are the same integers. A perfect square trinomial is a product whose factors are the same binomials. So in this case, I have two binomials that are the same. So two terms, x minus 3 and x minus 3, multiply together, give me x squared minus 6x plus 9. All right, difference of two squares is very important, just because difference of two squares is used quite frequently in math, and being able to identify the difference of two squares will help you with your speeding up your transactions and helping you to understand math a little bit more quickly. So what we're looking for is two perfect squares. One is subtracted from the other. So 1 plus and 1 minus value. So x squared minus 4 is an example of difference of two squares. I can factor that into a plus b times a minus b, or a plus 2 times a minus 2. So the factors of the perfect square would be a and b. So a plus b times a minus b. Also 16 minus x squared is a difference of two squares. The difference of two perfect squares. That's what we're looking for. This is 4 minus x times 4 plus x. Right, a perfect square trinomial can be written as a plus b squared, which is a squared plus 2ab plus b squared, and a minus b squared, which is a squared minus 2ab plus b squared. So the two examples would be x plus 3 squared, which is x squared plus 6x plus 9, and x minus 2 squared, which would be x squared minus 4x plus 4. So these perfect square trinomials, over time, as you deal with quadratics more frequently, you'll be able to spot them pretty quickly. And that's the idea, is to find some intuition around quadratics, both in terms of difference of two squares and perfect square trinomials. But at least you know what they mean at this point. All right, so let's talk about factoring quadratics. I'm going to go through each of the steps. The first step is to look for common factors in each term and separate from the expression using the distributive property. So an example would be 8m squared plus 56m minus 120. The common factor is, in each term, is going to be 8. So 8, I'm going to distribute out the 8, and I end up with m squared plus 7m minus 15. Now you can go through what I'm going to teach you, diamond and box factoring, with this entire trinomial without distributing the term out, but it's going to take you longer to go through that process because there are a greater number of possible outcomes to evaluate. So the first thing we want to do is simplify that quadratic as much as possible by distributing out any common factors. And of course, 7 is a common factor in this example. All right, so next we want to use, we look for special product patterns quickly, and then we distribute out a common factor. And now we're going to use a diamond and box to factor. All right, so diamond and box should be something that you're familiar with from algebra. So I'm going to go through this quickly. You might have your other method of factoring quadratics, and if there's another method that works better for you, that's fine. So I'm just going to teach the diamond and box process so you have something in your pocket to use. Ultimately, we want this to be an intuitive process. All right, so you're going to create your diamond here. That's really an X. And the top part of the X, the diamond, you're going to put AC, A times C. So this would be 1 times 8, or 8. And then the factor of 1 and the factor of 2 that add to B. So the factors of A times C, that's what you're looking for, that add to B. So you're going to have to play around with it. I have 1 and 8 and 2 and 4. 1 and 8 do not add to 6. And it can also be plus or minus 1 or 8. And then 2 and 4. 2 and 4 add to 6. So the factors of A times C that add to B. And I'm going to put those factors here along with B at the bottom. All right, so next thing I'm going to do is I'm going to create my box. And there's a lot of detail here which you can read, but I'm going to go through this. In the upper left, I'm going to put the first term. And in the lower right, I'm going to put the last term. So upper left is ax squared, and the bottom right is c. And then in the lower left and upper right, I'm going to put the two values in the left and right here of my diamond. It doesn't matter in what order. I could put 2x here and 4x here, but I have to add that x next to them. So 4x and 2x. All right, and then I'm going to take the common factor in the rows and common factors in the columns. X is a common factor here, 2 is a common factor here, x is a common factor here, 4 is a common factor here. And now I've factored my quadratic. All right, so again, outside next to the box, place the common factors of the rows and columns above and to the left, and use these to create my factored quadratic, and here is a factored quadratic. All right, so let's do an example with a quadratic where a, this value is greater than 1. So I want to follow the same steps as you would with a quadratic where a is 1. But again, this top value here is a times c. So this is going to be 24. Bottom is going to be 10. And then the factors of negative 24 that add to 10 are going to be negative 2 and 12. So again, you're going to have to play around with this. I just go through each of the factors 1, 24, 2, 12, 3, 8, 4, 6, etc. And then I match them up and I try to find that b value. All right, so then I'm going to place upper left is ax squared, bottom right is negative 8. And then the factors here in the left and right that add to 8, I'm going to put them in the lower left and upper right, doesn't matter which order. And then I'm going to find the common factors in the row and then the columns, and I'm moving through this quickly. And I end up with x common factor here, 4 common factor here, negative 2 common factor here, and 3x common factor in the top row. And so I've factored my quadratic. All right, we're going to pause here. I'm going to go through an example, and I'm going to give you some classwork.